Welcome back to part 2 of our video on drawing trig graphs. So we're on D, y equals -2 cos x plus 135 plus 3. So the first step is to do our axes. So every third square is 90 degrees. -90, -180, up to +5, down to -2. So there we've done our scales. And then we're going to draw one cycle of our parent. In this case, our parent is y equals cos x. And the 5 important points for that are 0 and 1, 90 and 0, 180 and -1, 270 and 0, 360 and 1. And then we've got our smile here, going into a frown, going into a frown. There's our one cycle. Now I'm going to color code vertical and horizontal transformations. So there's a vertical, there's a vertical, and there's a vertical, 3 verticals. And here's one horizontal. So then I'm going to list out our vertical transformation. So the negative is a vertical reflection. The 2 is a vertical stretch by a factor of 2. The 3 is a vertical shift, plus so up 3, but that's 6 squares. Don't forget to do that. I'll put a little star there. And then the green is a horizontal shift, and it's left because it's plus, and then you have to do 135 divided by 30 to see how many squares it is. So that's 4.5. So it's left 4.5. Well, first let me write left. 135 degrees, which is 4.5 squares. Okay, so then we're going to use that information to shift each of these 5 important points, and then we'll have one cycle drawn of our image, and then we've got to extend it for 2 cycles. Okay, so starting here, vertical reflection, so down at -1, vertical stretch by a factor of 2, so down to -2, vertical shift, so up 6 squares, 1, 2, 3, 4, 5, 6, and then left 4.5 squares, 1, 2, 3, 4.5. So there's the image of this first point here. Next point, vertical reflection, still at 0, vertical stretch, still at 0, still in the x-axis. Up 6 squares, 1, 2, 3, 4, 5, 6, left 4.5, 1, 2, 3, 4.5. Vertical reflection, so up to +1, stretch, up to +2, up 6 squares, vertical shift, 1, 2, 3, 4, 5, 6, and then left 4.5, 1, 2, 3, 4.5. Vertical reflection, vertical stretch, still stay on the x-axis, up 6, left 4.5, vertical reflection, -1, stretch at -2, up 6, left 4.5, 1, 2, 3, 4.5. Okay, so those should be our 5 important points to draw one cycle of the image. So here I see a frown, and then going into a smile, and going into a smile. And then there should be a pattern that we can see that we can extend to get our second cycle. So our pattern is, so over 1, 2, 3, and then up 1, 2, 3, 4. Over 1, 2, 3, up 1, 2, 3, 4. Over 1, 2, 3, down 4. Over 1, 2, 3, down 4. So we're going to go over 1, 2, 3, up 4. Over 1, 2, 3, up 4 again. Over 1, 2, 3, down 4. Over 1, 2, 3, down 4 again. 1, 2, 3, 4. So that should be our second cycle. Okay, so our central axis is moved to where our vertical displacement was at 3. And we can see that our amplitude is from 3 up to 5, which is 2. So our amplitude is 2, which you can see was our vertical reflection. And remember, amplitude's never negative, okay? So the negatives just makes it a reflection, doesn't affect the amplitude. Our period, so max to max is 1, halfway, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 squares times each square is worth 30 degrees, which is 360 degrees. Or you could also get it by doing 360 divided by the b value. And the b value is a 1 this time, okay? So there's no number out front like there would have to be here between the cos and the x, okay? So the b value is just a 1, which makes it 360 this way as well, using the equation that we're given. Phase shift, P dot S dot, is so left 135, so negative 135 degrees. And then we need to do domain for what we drew. So the leftmost is halfway between negative 90 and negative 180, which is negative 135 degrees. Or you can think about 30 and then 15. And then the farthest right we go is 570 and 15, 585. And then our range, lowest to highest. The lowest we get is positive 1. And the highest is 5. Okay. And E, y equals 2 sine negative 2x plus 90. Okay, big star beside this one. First, we'll just do our scale like we normally would. 180, 270, 360, 450, 540, 630, negative 90, negative 180, okay, and then again, still we're going to draw one cycle of our parent. So our parent is y equals sine x. So that starts at 0, 0, then 90 up to 1. There we go. So there's our one cycle. Now we would normally start color coding our vertical and horizontal transformations, but there's also that, do you remember, is it ready to color or is it not ready to color? And that means if there's two things happening with the x, it has to be in factored form, which it's not. So we have to rewrite it before we can color code it and factor out the b value, which is -2. And then -2x divided by -2 is x. And then 90 degrees divided by -2 is -45 degrees. So that now we have the correct phase shift or the correct horizontal shift. So now it's ready to color code. So there's our vertical transformation. And we've got three actually horizontal transformations: a horizontal reflection, a horizontal compression, and a horizontal shift. So let's write these out now so we can apply them. So we've got a vertical stretch by a factor of 2, a horizontal reflection, a horizontal compression by a factor of 1/2, and a horizontal shift, and it's negative, so it's right 45 degrees, and then 45 divided by 30 is 1.5, so 1.5 squares. So then we're going to use this to draw our 5 points that should form one cycle of our new function. So vertical stretch by a factor of 2, we stay here. Horizontal reflection, stay. Horizontal compression, stay. Shift right 45 degrees, so right 1.5. This one, vertical stretch by a factor of 2, horizontal reflection, so I'm going to be over at -90. And then divide that by 2, so halfway is -45. And then right 1.5, so end up right here. And then 180 here, vertical stretch by a factor of 2 is stay on the x-axis. And then horizontal reflection, so from 180 I go over to -180. Then I half it to -90 because that's my horizontal compression. And then I shift right 1.5. So I've done 3 of my points. 270, horizontal stretch by a factor of 2 down to here. Horizontal reflection, -270 isn't over here, but I'd be thinking, okay, I'm going over to -270, but then I'm halving that, which puts me at -135. So that's going to be halfway between -90 and -180. That's -135. And then shift right 1.5 puts me here. All right, 360 vertical stretch, I stay here. Horizontal reflection, I'm way over at -360, but then I half that, so I'm going to be at -180, and then shift right 1.5. So this 1, 2, 3, 4, 5 points should be one cycle. So I've got a frown and a smile. And then there should be a pattern that I can see to get from point to point. So it's over 1.5 squares down 4, over 1.5 up 4, over 1.5 up 4, over 1.5 down 4. So I'm going to go over 1.5 down 4, over 1.5 up 4, over 1.5 up 4, over 1.5 down 4. And then I should be able to draw my second cycle in. Okay, so there's my 2 cycles. Amplitude, so my central axis stayed at 0, and the distance from the central axis to the maximum is 2. So the amplitude should be 2, which is also the number out front. So that's works. The period, so the number of squares from maximum to maximum is 1, 2, 3, 4, 5, 6. So 6 times 30 is 180 degrees. But I can also use my formula. Period is 360 divided by the b value. And the b value is 2. So it's 180 degrees. Remember, the negative just makes a horizontal reflection. It's not the b value. It doesn't affect the period, the negative. Phase shift, and this is where we had to put it into factored form to get the correct phase shift. So instead of being left 90, if we had forgot to put it in factored form, it's right 45, so 45 degrees. And then domain and range for what we drew. So the domain leftmost we get is negative 135. And the rightmost we get is, so it's going to be 210 and 15, 225. And the range, all real numbers y, as long as the lowest we get is negative 2 and the highest is positive 2. Okay, and again, I started that one because you had to put it in factored form in order to get the correct phase shift and thus the correct graph. Okay? All right. So here's a summary. If you're given a function y or y equals a sine, and this can also be cos, so it works for cos, same as sine, b x minus h plus k, you can get the amplitude right from the equation by taking the absolute value of whatever the vertical stretch or the a value is. An absolute value just means amplitude is always positive. You can get the period right from the equation by using the formula. Period is 360 degrees divided by the b value. And note that the b value also represents the number of cycles that fit in 360. So if we look back, this b value is 2, and it means 2 cycles fit in 360 degrees. Since the period's 180, and the period is how much it takes for 1 cycle, then 180 times 2 is 360. 2 cycles would fit in 360 degrees. The phase shift is the h, okay? And if there's a minus, it's just right, so you just leave it positive. If this was a positive in here, then your phase shift would be negative. And it's in degrees, remember, and so is your periods in degrees as well. And your amplitude is just a number. The maximum value can be found by adding the amplitude and the vertical displacement. So k, which is where your central axis is, plus the amplitude. So let's see if that works out. So here's a question. So if I just wanted to get my maximum value from this equation here, it says take my k value, which is 3, and add my amplitude, which is 2. 3 plus 2 is 5. Then you can also see here's my central axis, plus my amplitude, which was 2. And you can see here we shows our amplitude 2. 3 plus 2 gives me 5. So there's kind of like a formula that gives you the maximum. It's the k value, which is your vertical displacement plus your amplitude. And your minimum value, similarly, if we look back at this question here, is your k value, which was 3, minus your amplitude, which was 2. 3 minus 2 is 1, and that does turn out to be our minimum. Okay, so to get the minimum, you can do k minus a, which means that we should be able to fill out a chart like this without having to draw our pictures. So we'll go through column by column. So we'll look at all of these trig functions and figure out their amplitude first. So the amplitude for this one is the vertical stretch, so it's going to be 2, 3. There's no vertical stretch, so the amplitude is going to be 1. Here, remember, amplitude's always positive, so that negative just makes a reflection. So the amplitude's 2 because it's vertically stretched by a factor of 2. Here, our vertical stretch is 5, and here our vertical stretch is 4. So those are our amplitudes, our distance from the central axis to the maximum. The period, we can use the formula. Period is 360 degrees divided by the b value. So here the b value would be between the sine and the x. It's a 1, so the period's 360 degrees. Here the b value is a 2, so 360 divided by 2 is 180 degrees. Here the b value is a 3, 360 divided by 3 is 120 degrees. Here the b value is a half, so that's actually a horizontal stretch by 2. So, and 360 divided by a half is 720. So that's really stretching it out horizontally. So instead of it taking up 360 degrees for one cycle, it takes 720 degrees up for one cycle now. Here my b value is 3 again. 360 divided by 3 is 120. And then here my b value is a third. So 360 divided by bracket 1/3, so I could do 1 divided by 3 in brackets as 1/3, or use my fraction button, and you get 1080 degrees. So this one's really stretched horizontally. Okay, so we did period. Phase shift, we should be able to get from the equation as long as it's in factored form if it needs to be. If it's not, then we would have to do that. So here, it doesn't need to be in factored form because there's just one thing happening horizontally. So our phase shift is 135 degrees to the right, which is positive 135 degrees. Here we see that we have two things happening in the brackets with the x. So to figure out the correct phase shift, we would have to put that part into factored form. So it would be 2, and then x plus 240 divided by 2 is 120. So that means our phase shift would be left 120 or negative 120. Here we don't have x plus or x minus anything, so our phase shift is 0 degrees. Same here. Here we have 3x plus 180, so we have those two things happening in the brackets with the x again, so we have to put it into factored form. 180 divided by 3 is 60, and its plus is left 60 or negative 60. And then in the last one, it already is in factored form, so the phase shift is negative 60 again, left 60 or negative 60. Maximum value, it's the k, which is the vertical displacement or vertical shift, plus the amplitude. So there's my vertical shift k, 1, plus the amplitude, which is 2, means my maximum value is 3. Here my k is 0, plus the amplitude is 3, gives me a maximum value of 3 again. Here my new central axis is at negative 5, so my k is negative 5, plus my amplitude, which is 1, is negative 4, so the highest it ever gets is negative 4 for maximum. K is 3, plus my amplitude, which is positive 2, because amplitude's never negative, so 3 plus 2 means the maximum value would be 5. The k is negative 4, so my central axis is now down at negative 4. Adding the amplitude of 5 means the highest I would get is positive 1. This new central axis is at negative 1. Add the amplitude 4, and my maximum value would be 3. So for your range, I want us to think of it as the range is always going to be the minimum value is less than or equal to y is less than or equal to our maximum value. Okay, so we already know our maximum value. The minimum value we said was k minus the amplitude. So to get my minimum value here, I do my k minus the amplitude, so 1 minus 2 is negative 1. And I already figured out my maximum, so my range would be between negative 1 and 3. Minimum, again, so the K is 0 minus the amplitude, so 0 minus 3 is -3 to my maximum. Range for this one, the minimum, so -5 minus 1 is -6 to my maximum. And the span of the range, so from -1 to 3 is 4, that should be always twice the amplitude. Because if you think about a trig function, if you divide it into the central axis, it always goes the same amount down as it went up. So if it goes 2 up from the central axis, it's going to go 2 down. So it's always going to be double the amplitude. Your span should be in your range. So it's a good way of checking it. Okay, so my minimum value, K3 minus 2 is 1. Remember, amplitude's not negative, so don't get make a mistake there. 1 to 5 is 4, which should be twice the amplitude, and it is. Minimum, K minus the amplitude, so -4 minus 5 is -9 to 1. So that's a span of 10, which is twice the amplitude. Our minimum here, -1 minus 4, -5 to +3 is 8, which is twice the amplitude again. So there we can fill out a chart that gives us a lot of knowledge about the trig functions without actually drawing them. And here's our success criteria for sketching the graphs of trig functions, which is this week's topic. We can draw and label x and y axis showing the scale, 30 degrees for the x-axis. We can draw one cycle of the parent function, so it's either going to be sine or cosine using the 5 important points. Can make a list of transformations. Remember, stretches, compressions, and reflections come before shifts, and we know that if 2 transformations are occurring with the x, you must make sure it's in factored form. You can apply the list of transformations to each point of the parent function to sketch one cycle of the image. Be careful about the scales of each axis. Remember to write down the number of squares so that you don't forget that going up or down, if you go up 1, you're actually going up 2 squares. You can extend, we didn't do an erase question, but we can extend to 2 cycles by figuring the pattern out. We can label each graph with its equation, and we can use our knowledge of transformations to check our graph. So that's a good point here that we didn't quite go through. So again, our word should match our picture. So we've got our parent drawn on here. Oops. Got our parent sign drawn on here, and we said in words that we should have it vertical stretch by a factor of 2. So our image should be twice as, the amplitude should be twice what it was for the parent, which it is, and it should be horizontally compressed by a factor horizontally compressed by a factor of 1/3, which again it is. So here's one cycle, now here's one cycle instead. Okay, which it takes up 1/3 as much. So again, you should always make sure that your, number 7, you should make sure that the words you list down match your picture. And another good one is if you've got a vertical shift, that's where your central axis should end up. Okay, is your maximum value correct? All those kind of things, you can figure them out using all those strategies we use for the chart and make sure that your graph is correct. Okay, thanks everyone.